All right, the last two examples that we're going to talk about in this section on solving exponential and logarithmic functions have to do with some sort of application of those functions. In this first example that we're going to look at together, I think this is kind of a funny problem. They talk about, it gives you a model already. In other words, it gives you an equation. And the equation or function is modeling the percentage of students who can recall important features of a classroom lecture as a function of time. So in other words, the y-axis is talking about the percentage, how much of the lecture they remember, the percent of the lecture they remember after so many days. So it's a percentage of what they remember as a function of time, which is represented as x. Okay, so the first question says, after how many days do only half the students recall important information of the lecture? And then be able to state your response in context with the problem. So the function that we are given is already over here for us. It says p of x is equal to this logarithmic function. And the question says, after how many days do the students recall only half of what they remember? Half of what they remember would be 50%, or in this particular case, 50. So p of x, which is what they remember, would be equal to 50. And the function is 95 minus 30 log 2x. So in other words, 50 would be equal to 95 minus 30 log 2 of x. And that's because p of x was equal to 50. So we set the equation equal to 50 and solve for x. So we have only a single log function showing up in this equation. And so I'm going to isolate this guy by itself. I'm going to subtract 95 to the left-hand side, which gives me negative 45 is equal to negative 30 log base 2 of x. So I'm still trying to get this one by itself, so I divide both sides by negative 30, and I find out that this is 1.5 is equal to log base 2 of x, because I divided the right-hand side by negative 30 and the left by negative 30, and that gives me 1.5. Now that I've isolated the log portion of the equation, I'm going to rewrite it using our definition of logs. This is a base of 2 raised to the exponent of 1.5 equal to the argument x. So I can put 2 raised to the 1.5 in my calculator, and I find out that that is approximately 2.8. Now what does that mean in context to our problem? What that says is that after only 2.8 days, 50% of the lecture is remembered. So it's only less than 3 days after a lecture and students have already forgotten half of what they learned. So, which I think is kind of funny as a teacher. All right, now let's look at the next problem here. It says, okay, well, after how many days will the students have forgotten all the important features? So will they, after how many days will they remember nothing? So we are going to say that p of x in that case would be equal to 0. So they remember 0% of the lecture. So we're going to set that equal to the equation p of x, which was equal to 95 minus 30 log 2 of x. And we go about solving this in the same way we did the previous problem, or the previous part. So I'm going to subtract 95 to the left-hand side. That's equal to negative 30 log base 2 of x. I'm going to divide both sides by negative 30, and I'm going to leave this as a fraction right here, is equal to log base 2 of x. And the reason I did that is because 95 divided by 30, or negative 95 divided by negative 30, gives me a repeating decimal. So I'm just going to keep the number as is for the meantime, so I don't have any rounding errors. Now that I have the log portion isolated, I'm going to rewrite it using the definition of log. So this is 2 raised to the fraction 95 over 30 equal to the argument of x. So this part right here is what I'm going to put into my calculator. And when I do that, 2 raised to the 95 over 30, you should get approximately 9. So what that says is that after 9 days after the lecture, Students don't remember anything that they were taught. So that's how you're going to handle this particular problem where they're already giving you the function. Kind of a funny question. All right, let's move on to this next one. I don't know if you are aware of the game Call of Duty, but that's what this particular question has to do about, has to talk about. It's talking about the revenue on this type of, or on this game from this company. So this is kind of telling you about Call of Duty if you didn't know what it was about, but we're going to skip down here and we're going to look at this this portion of the question. So I have a table over here, and this table is showing you that the annual retail sales for the Call of Duty for these years that are shown here on the left column. And this is the corresponding retail sales in millions of dollars for each of those years. What we're being asked to do is we're going to create a scatter plot representing this data right here, and we're going to decide whether or not that scatter plot looks like a log, exponential, or a linear function to then come up with the equation for that line. So you want to make sure that you have your graphing calculator out so that you can do a regression on it, and we're going to walk through this together. Typically when you do a regression, you put data from lists like what we have here into the lists on our calculator. And so what we're going to do is we're going to let this year here be list number 1. That's typically the independent variable, which is what our year is. And the second column, the dependent, is typically L2. So the retail sales depends on the year, so we're going to let L2 be the sales and L1 be the year. Now I don't want to put 2004, 5, 6, and 7 and so forth into my calculator, so instead what I'm going to do is I'm going to let 2004 be represented by 0 and 1, 2, 3, 4, 5, 6. So these are the numbers that correspond with 2004 through 2010. And that's what I'm going to use to put into my calculator for L1. And then these values over here, 56 through 980, those are the values that I'm going to put into L2. So, in case you don't remember how to do that, let's pull up your graphing calculator here, and I am going to go to Stat. So when I click on the Stat button, I have this menu over here on the right-hand side, and I'm going to edit what I see there. Now, I've already put this information in my L1 and L2, but let's say, for example, that you click on your lists and you have data already in the lists that you're seeing, but it's not the data that we're talking about here. It's just data from a previous problem. In order to get rid of that data, you're going to arrow up until the heading here, either L1 or L2, is highlighted, and you're going to hit Clear. Clear is the part that is going to get rid of the data in that column. Don't hit delete. Delete's actually going to delete the entire column, and you won't have an L2 showing up at all. And it's kind of confusing how to get it back, so just don't do it. Hit clear in order to clear the list. So again, I've already got my data entered into the lists. And so from here, I want to make a stat plot. I want to create a plot of the data, representing the data. Before I do that, you need to be aware that the window has to be adjusted, more than likely on your regression, so that you can see the points that you're plotting. So I'm going to let the data that we have in our lists guide me on how I want to start my window. You might have to adjust it at some point, but this is how I'm going to start. So the x values, which are represented by L1, if I look at the x values here, I have x values from 0 to 6. So I'm going to say that I want my x min to be 0, the max to be 10, and my scale is going to be 1. And we'll do this together in a second, but this is what I want to have happen. L2 represents the y values. Notice that I have y values from 56 to 980. So I'm going to just start my y values at 0 also, and I want to go all the way up to 1,000. So notice that I go a little past my maximum value, and I don't want to see 1,000 different tick marks on the y-axis, so I'm going to put the scale or increments by 100. So if I go to my window, you can see that I have that set already here. X min is 0, X max is 10, scale of 1. Y min is 0, Y max is 1,000, scale of 100. The next thing you have to do, you want to make sure that you have turned on in your calculator to create the scatter plot. You're going to have to turn on stat plot. So I go over here to Y equals. I'm going to arrow up until the word plot 1 is highlighted and flashing possibly, and I'm going to hit enter. Now I accidentally turned mine off, so I'm going to turn it back on. So when I come down out of that spot I was in, your plot 1 should be highlighted. That's indicating that the plot is actually on. Now I can go to the graph since I have the window adjusted, and I can see what this looks like. So each of these blue boxes on my screen represents the ordered pair for these points over here. So remember, along the x-axis we had the year, along the y-axis we had retail sales, and here is the plot representing the data from my table. Now we're asked to determine, based on this plot, what do you think that this graph looks like? Does it look logarithmic? Does it look exponential? Does it look linear? Well, I don't think that it's linear because it looks to me like it's curving. I don't think that it's logarithmic because logarithmic would be coming up and moving across like that. But I do believe that this is an exponential function. So I am going to go get the regression equation, the exponential regression equation that is, it may be the best fit for this line right now. So I go back to stat. This time I'm going to arrow over to calc. Now the exponential regression that I'm looking for is actually at the bottom of this list, so I'm going to arrow up to go to the bottom of the list. And you can see here that number 0 is my exponential regression, so that's the one I'm going to choose. And here it brings up a window for me. So I have, it's telling me that I'm going to look for my regression equation, that I'm going to use the x values are going to be on L1, the y values are contained on L2, and then I'm going to arrow down here to store the regression equation because I want this to be stored directly on my y1 line on the y equals. To do that, I'm going to hit alpha F4. And you can see this little window that popped up over here. And one of the choices is to put this on Y1, which is number 1. And I'm going to go down and hit calculate. So the regression equation for the data that we were looking at is given to you here. And it gives you the equation at the top, and then each of the letters that are represented are down below. So this is going to be, and let's just take this and drag it over to our window. So we know what the equation is going to look like, and it put the equation, this equation with all of these decimal places, directly on my y1. So if I go to y1 or y equals, you can see that equation is listed for us here. Now let's just see how well this equation actually does fit my data. So I'm going to go to graph, and it should graph the linear or the exponential regression on top of the data that we are looking at. And here it's a pretty close fit. I would say that it's probably the best choice for what we're doing right now. And so that's the equation that we're going to use. Now let's just write it down. So my equation comes from the y equals a times b to the x. So my a that we're going to use to 2 decimal places looks like y equals 65.76 times 1.62 raised to the x power. And that is the equation that we're going to use to represent the data that's over here. And that's how we can do a regression to come up with an equation based on some real data that we're looking at.